Hello and good evening. My name is Shounak and welcome to Physics for Students to this special evening today where we will be discussing about critical thinking. I already got a message from Asif Shahriar telling eagerly waiting. Rahat Pirzada is already there. Very good evening, Rahat. And I would like to talk on a very important issue today. And I can tell you that it won't be one episode. I won't be able to finish up the entire process of what is the critical thinking through this one particular episode, but I would like to do as much, I mean to say, as I can. Now, just to inform all of you that this critical thinking is something which is not of a lecture. I mean to say, I won't be able to tell you much about critical thinking, that you need to do this, you need to do that. Now, the thing is that this is more of a practice. Are you getting my point? So you really need to take up those things and you really need to go ahead and practice them. Otherwise, all those talks, you will be sitting down now, listening to me, and you will be expecting those results. But again, I'm taking you, critical thinking is something which you need to practice. Whatever I am telling right now, out of my experience, out of my teaching in college, yes, from Ottawa, His Highness, very good evening. Whatever I am telling, this is fine, but you need to practice. Now there is a process of practice. It's not just to you wake up in the morning and you start. I will tell you also the process, but my request to you is that let us make this a kind of a process that we will be speaking. I would be telling you whatever I can. You will exchange your ideas. And then after 10, 15 days, either in my email or on this live section in the comment box, let me know how are you practicing. Let me know how things are progressing. Because I'm telling it is a matter of practice. There is no point that you just listen to them. So, having said that, I would first like to tell you what is critical thinking. Now, this is again not a very bookish definition. This is a definition which will make you understand about the process of critical thinking. Until you understand this, you won't be able to, do critical thinking. So the first thing is that critical thinking is the analysis of available facts. Now, those which are written in, I would say, yellow, these are important. Evidence, observations, and arguments in order to form a judgment by the application of rational, skeptical, and unbiased analysis and evaluation. So we are taking away a few things from this definition. First is there should be enough amount of available facts. Second thing is that remember that we are forming a judgment. That means you are acting more as a judge. And I will soon explain to you that there is a difference between critical thinking and normal thinking. Obviously, there is a difference. We need to look into that. Next, what we do is that we have to be very skeptical. I mean to say, I will tell you what it is: skeptical, being skeptical, doubtful. How do you do that? And most importantly, you have to have an unbiased analysis. So first, there should be lot of facts. Number two, remember that you are forming a judgment. That means you are telling this is right or this is wrong. That judgment has to be very made in a very skeptical way, and there should be unbiased analysis. So available facts, judgment, skeptical way, unbiased analysis. I would say these are the four key takeaways from this definition. Let us remember that. This is another definition which more or less thinks in the same way, but this is also important. Critical thinking is the intellectually disciplined process. Now, this is very important. Intellectually disciplined process means critical thinking cannot be just a person is born out of the, he or she is born and then he become a critical thinker. No, he can be a thinker. He can be a thinker, but not a critical thinker. That means it is an intellectual process. You have to acquire that skill, just like bodybuilding, muscle, marathon race, etc. You cannot be a born bodybuilder or a born racer. You need to practice this thing. That is why I told at the beginning of this lecture that let us practice. No point in listening to me until you practice. Of actively and skillfully conceptualizing, applying this, observation, experience, reflection, reasoning. So the key takeaway from this definition is that it is an intellectually disciplined process. That means you have to follow a discipline, you have to do that, and you have to be actively and skillfully doing all those things like conceptualizing, applying, analyzing, synthesizing, etc. So having given these two definitions, what we can understand from here is that this is an acquired skill. I hope, are you getting my point, Asif, Rahat, and others who are listening? It is an acquired skill. An acquired skill means, say, for example, if I know German as a language, then it is an acquired skill because German is not my mother tongue. And if I don't practice, maybe I won't be able to speak or write fluently German after 6 years or 7 years. Number one. Second thing, it is an intellectually disciplined process, which means that you need to be disciplined and you need to practice it. That is very important out of these two definitions. It is based on available facts. You cannot make a decision based on few facts. It has to be judgmental, and you have to be skeptical, and you have to make it on unbiased analysis. This is very important. I say even God is very biased. That is why God made us human beings as the greatest animal. So you have to be very unbiased. That is very important. So you see, it actually comes from this Latin and Greek word criticus or critikos, from crits, which means a judge. So you already got this point. That means it is not a very, I would say easy, but it's not a very simple thing to do. You have to act and you have to become a judge. And I hope you understand that being a judge becomes so very important and so very crucial. What type of critical thinking should we apply to understand and solve mathematical? Yeah, the Sashank. So that is what I am coming to. Once you listen to this, you will yourself get the answer. What type of critical thinking you need? Thank you for joining the show. Yes, sir. I learning from online classes, Malayalam language, yeah, and Pashto language, right. I already know basic Arabic, also Hinko Kashmir, right. So Rahat Pirzada, I would like to introduce him that he is a very noble person. He's doing a noble job by teaching to special education people who cannot see or either hear. So he is already doing a very wonderful job. Kudos to you. And he is saying that I'm learning all those languages. That means he is trying to say that it is an acquired language. So first of all, from our definition, we need to find out that we should get enough data. So when we talk of getting enough data, that means a total analysis, critical thinking, whatever kind of critical thinking, mathematical, physics, whatever that is you are doing, that means you have enough amount of data. That means your channel, say for example, have 5,000 subscribers, and out of that only 10 people or 12 people are coming to live. And based of that, you are making a percentage. That means this much interested people are interested in physics or mathematics. That is wrong, because you don't have the data. If 10,000 or 5,000 is your subscriber base, then at least some portion has to come to watch it. You just cannot make a kind of a understanding. Got my point? Yeah. You cannot just tell that, well, those many people are coming to my channel or to my live or to they are liking or subscribing. That means no. So the percentage of people who are on your channel and the total percentage, substantial percentage, if they're not coming to listen to you, it cannot be a comparison. That means you don't have enough data to do an analysis. So my first request would be that whenever doing a critical analysis based on a mathematical theorem, based on a physics theorem, you want to become a theoretical physicist, you are creating a nice theorem based out of data, you are doing astronomical observation, you are doing anything, first find out that whether I have sufficient data or not. Now, different type of disciplines have different kind of data. I'm not going all to that. As I told you, I will be again speaking again maybe a day after tomorrow on that, because tomorrow we have an important podcast. But getting the sufficient amount of data is very important. If it is a mathematical thinking, the data should be certain way. If it is a thinking in terms of physics, it has to be. So if a person who is an astronomer or astrophysicist, if he or she is analyzing the based on data, then there has to be a certain amount of data which has to be present. Otherwise, if I make an assumptions that these stars glow blue because of this, no, that means I don't have enough amount of data. So this is very crucial. Try to understand and get a data. The next thing would be observation and active listening. Now, there is a difference between listening and active listening. Can anybody tell me what is the difference between listening and active listening? I will wait for that. Listening and active listening. What is the difference? It would be great if you make a video of quantum physics and quantum mechanics from the viewpoint of finding God and Ramakrishna, Paramhans, and Swami Vivekananda's talking. Yeah. Okay. Anyway, that is a different issue. So, active listening actually includes what I would say responses that shows that you understand what the other person is trying to tell. That means you're responding to that, right? Okay, so you told that, that means that is called an active listening. When you're reflecting on what is just what is happening. An observation, Rahat Pirzad has rightly told, is just to see. So that is also equally important. Second thing is that you have to be, observation is going, perspective, active listening is engaging. Yeah, Lady T is my name. Okay, very well said. Okay, Lady T, may I know your name, please? Because I don't want to call you by this nickname. It would be great if you can just put up your name. So this would be an accurate and right definition. Observation is mostly gaining a perspective of what people are telling, or some kind of a thing, as Lady T has rightly told. And active listening is engaging. That means you are telling something, I'm reflecting based on that. So that's an absolutely good answer. I can move on to the next because she has already answered. So if you can please put up your name, I will be highly obliged. Intellectually disciplined process. Now this word actually tells that it has to go on and on and on and on. It is not a one-time process which will happen. It is an intellectual process that we understand there has to be a lot of intellect involved in it. I will come to that giving you examples, but it is an intellectually disciplined process. That means every time, every day, we get to do that. Otherwise, it is not possible. Otherwise, critical thinking is never going to come. Now we come to the next important part. So these are actually from the definitions that we saw, isn't it? We need to get a good amount of data. We need to have an observation and active listening. We need to be very skeptical and unbiased. We will explore on that. And we have to have an intellectually disciplined process. That means we have to practice each day and we have to be very disciplined. Okay. We come to the next point, that why is critical, I would say critical thinking is important. Until we understand the why part, we won't be able to do that in a very good way. Active listening means listening carefully with attention. Yeah, not only attention, but to reflect and demonstrate that you understand those things. So rightly. Okay. So first of all, not only remember this this critical thinking skill is not only responsible for your physics and mathematics. That is only a very small part of your life. Critical thinking might be able to create a very good relationship. Critical thinking might be able to get you a good job. Critical thinking might be able to solve lot of critical problems in your life, husband wife relation with your family, with your parents. Lot of things are involved. So again, as I'm telling you, this is a very, very, very important topic. And I have seen a lot of critical thinkers who actually succeed in life. Forget about physics and mathematics. That is one part. Obviously, Shashank and others would be practicing creative active listening over there. But remember, as I had a video that why mathematics is important in education, why we should learn algebra. It has nothing to do with math. We learn mathematics because we think we will learn mathematics for our career, research, etc. But mathematical brain can solve a huge amount of problem, personal problem, business problem, financial problem, your personal problem with your boss. I'm telling you, this is so very important. Critical thinking, mathematical learning, mathematical thinking of mind, abstract thinking, it has very small percentage to do with your career, with your science, with your mathematics, but a huge amount of to do with your boss, with your mother, with your father, with your wife, with your daughter, son, everywhere. So here you see that it enhances problem solving skills, refine your research skills, evaluating mathematical arguments, polishes your creativity, lot of things, avoiding misinformation, identifying logical fallacies, analyzing experimental data, and helps to improve decision making. This is very important. Last part, you never know. You think that decision making is only in companies as boss or managing directors. No, even at family, when God forbid, touch wood, somebody is falling sick, somebody is not well, that moment you have to take a decision. That moment you have to make a phone call. That moment you have to talk to a doctor. Touch wood, everything is good by this year and the years to come. But decision making is a very, very important and crucial process. I've seen many team leaders, they really do fail in terms of a company, whether you have to sack somebody, whether you have to recruit somebody, huge amount of problems. And obviously the problem solving skills, once you're improving your problem solving skill, again, nothing to do with mathematics and science, in your daily life, with your daily routine, with your parents, with your mother, with your cousin, with your sister, you will see that you are getting a better decision. You will see that you will get a better creativity. Okay, what is the logical fallacy? Yeah, this is a very good question, Karan. I will come to that. Logical fallacy, in the sense, say for example, I am telling that, say for example, logical fallacy is something, for example, uh, I say that it is raining. No, not in that way. Logical fallacy comes in that way. So, for example, uh, how would I say? Okay, let me come to that part. Logical fallacy. I will just explain you. I mean to say, what would be the I would say example. I will come to that. Okay, so there are many types of logical fallacies which comes in. Anybody can give an example also of logical fallacies. For example, let me think. This is a good question. So I can say, you do not understand this proposal, okay, because you are stupid. Okay, you don't actually care anything. You just want to generate something like that. So errors in reasoning in order to, I would say, invalidate the argument. I will just come to that part. I will show you what is logical fallacy. Logical fallacies are different things. Say, for example, how would I say? A logical fallacy example would be, okay, I will come to that part. Let me go ahead with that. It's a very good question. Okay, now I will come to, okay, let me find out this. This keep on hunting me. Logical fallacy example. For example, let me show you one thing. For example, just I will give Karan's answer. Say for example, there are two type of arguments. Okay, say for example, if I say, if you go outside without a jacket, you will catch a cold. I will say in that way. On the other hand, if I say that if you go outside without a jacket, you will you will catch cold and infect the rest of the family, then your sister will have to miss class and she will get a bad grade and fail her course. So logical fallacies, actually there are different kinds of logical fallacies. It actually creates a kind of a problem that you really need to find out. So for example, say I say that all bachelors, say I would say that all bachelors, yeah, Dhrubajyoti. If I say, for example, all bachelors are unmarried, I'm going to say that is quite evident, isn't it, that bachelors would be unmarried. The earth is flat. I won't say it is a logical fallacy. Earth is flat is something I would say, uh, this is a kind of a statement. A logical fallacy, say for example, okay, just hold on for a second. I will give you an example. Logical fallacy. Mathematically, there are many. Uh, Okay, say for example, here it says that Dr. Smith, who is a famous scientist, says that eating 3 apples a day will make you longer. So it must be true. Okay, it is an appealing truth. The statement assumes that just because Dr. Smith claims that the apples must be accurate without considering other evidences and arguments. Okay, this is something which is called a logical fallacy. Okay, so what are the critical thinking that you need to do in physics and mathematics? Okay, first let me show you. You are always, thinking critically. That means, where, say for example, you have got a product which is claiming that this product will give you fairness, this product will deliver you this, etc. So if you logically, critically think on that, then you will possibly be able to understand what is that product claiming. So here it is. Hello, Drubha Jyoti Bhattacharya. Our researcher claims that they have found a new way to calculate the value of pi. Say, for example, a triangle has three angles equal to 180-degree. It will be a logical fallacy. I mean to say, you can call it. Right. So, for example, we have got a researcher who claims that there is a new way to find the calculation of pi. The value of calculation is something new. So, first thing is that, is the mathematical proof sound? That means whatever I am saying, is it sound? Sound means, is it okay, or there is a problem? This is the one thing that a critical thinker would think in this way. Second thing which comes is that, can you follow the logic and see how it leads to the conclusion? I hope I'm being able to make this point. So, if I make an assumption that there is a new method to calculate pi, then what happens is that, can I follow the logic to the conclusion? Is the method well tested? Definitely. Is the method well tested? We are trying to find, say for example, you need to find out that whether this method are well tested or not. So that these are the things which brings up to something which is called critical thinking. Is the method well tested? Is the method generalizable? Yeah, because every time we find any kind of a physics or a mathematics assumption or a research, first thing is that, is it generalizable? I mean to say, can I generalize things like that? Otherwise, it is not a system. Okay, then comes the point that, is, can it be used to calculate other mathematical constants? That means, if I find a kind of a formula, then can I make this to work with other constants? Are there any alternative methods that have shown to be more accurate? That means, if there are any other methods which shows this thing to be accurate, that means this cannot be a true evidence. So that means also it can be a kind of an understanding. That is also includes, which is called an I mean to say, critical thinking. So these questions should come to you before you make a kind of a claim that we have found a new way of calculating pi. So you need to evaluate the evidence. Say for example, again I say, I have found a new way to prove fundamental theorem of calculus. What is the source? What is the method used? The results, did it work for all cases? The limitations of the proof and the conclusions. That means these things needs to be evaluated properly. So you see, are you getting one point very clear, that critical thinking is something which is very close to proof driven mathematical system? In when we write a mathematical proof in real analysis, etc., we do the same thing. Is it going circular? Is it well tested? What are the alternatives? What could be the assumption? Is the assumption true or not? All those things which I just showed you here, these are all kind of a real analysis problem. Is the method well tested? Is it generalizable? Can it be used to obviously, because when you make an assumption, that assumption has to calculate other mathematical constants. Is there any alternative? Can you follow the logic? Is the mathematical proof sound? So you see, that means that is why critical thinking and critical thinkers can do well with real analysis, topology, or any kind of a proof based mathematical system. Because whenever I will come to another class where I will show you on pen and paper, I'm going to say using my Jamboard, that how do you write a proper proof. And when you're writing a proper proof, exactly all these critical thinkings should be considered. So what is the source, what is the method, limitations of the proof, and the conclusions. Here you see, Shashank was asking this, no, Karan was asking. So evaluating mathematical arguments. Say, for example, if I show you this, all even numbers greater than 2 are divisible by 4. Say, for example, don't worry about right and wrong. Now, all even numbers which are greater than 2 are divisible by 4. Now, what I say is that means all even numbers greater than 2. That means it can be 4, it can be 8, it can be 16, right? Now, the statement asserts that all even numbers greater than 2 are divisible by 4. Now, to evaluate this claim, we can counter example to test its validity. For instance, we can consider the even number 6, which is greater than 2. Now, is it divisible by 4? No. If it is not divisible by 4, the claim would be disproven. And this is exactly how a mathematical argument is framed in a real analysis, or a proof-based mathematical system. Okay, when I'm trying to say that set x comma tau is a topological space, and there are 3 conditions which proves this to be a topological space. First, phi would be included as it is an empty set, x and t would be included with a union, and x and t should be an intersection. Karan, you got it. Very good. So when I'm trying to make this kind of a thing, the first thing that is that, am I making a logical fallacy? Okay, I am telling that they are bachelors, but they are married. Something like that. Okay, it is raining, but but it is not cloudy. Something like that. I mean to say, let us discard that even it is not cloudy, then it also rains. Something. So logically fallacy. Statistical analysis. Yeah, so the basic thing is that these things should be taken care. I've shown you a very simple example, but proofs are based on this. So it says that all even numbers are greater than 2 are divisible by 4, but that is applicable to how many? 8 is divisible by 4, 16 is divisible by 4, 12 is divisible by 4, but not 6. But 6 is an even number. So now if I go back to this part of my slide, right at the beginning, getting enough data, that means we are violating this one. Are you all getting my point? If I say that any numbers, for example, this one, which I told that if any number which is, all numbers are greater than 2 are divisible by 4, I am doing a wrong thing. Why? Because I don't have enough data. That means other data like 6 is not falling in this scale. So if that is not falling, that means my argument is wrong. That means I'm not doing a proper critical thinking. Next example, identifying fallacies. Now this will answer Karan's question. Since 3 is a prime number, now watch it closely. What it has written. Since 3 is a prime number and 5 is a prime number, 3 plus 5 equal to 8, and 8 is also a prime number. Now you might say, no, sir, this is not true. I understand. But let us make a statement and try to analyze that. In this example, the fallacy committed is the fallacy of the undistributed middle. What is that? It occurs when 2 distinct terms share a common characteristic. This is very important. 2 distinct terms, 3 is a prime number, 5 is a prime number. They share a common characteristic. That means if they are added together, it will give to 8. And this would also give to another prime number. So logical fallacies are of many types of logical fallacies. I mean to say false dilemma, circular argument, there are many types. So this is called the fallacy of the undistributed middle. Now you or Karan or Rahat might be telling me, sir, do we need to know all the logical fallacies? Yes. Otherwise, how will you make a proof? How will you become a critical thinker? Because you need to identify which fallacy is under that. So this is called the fallacy of the undistributed middle, and it tells that it occurs when two distinct terms share a common characteristic. And it is mistakenly assumed that they are related and connected and they share a common characteristic. That means if I love mathematics and if Rahat likes mathematics, for example, and we have a common friend called XY, then I and Rahat would assume that person will also love mathematics because we and Rahat understand mathematics. Are you getting my point? This is the problem. So common characteristic, because I love mathematics, Rahat like mathematics, that means our common friend will also like mathematics. No. This is what is a logical fallacy. It is a fallacy of the undistributed middle. That means the middle one is not distributed properly. So to identify this fallacy, we can analyze the argument and recognize the error in the reasoning. Yeah, we should have enough data of any field, then we can critical thinking. If you're not knowledge, I love mathematics. Right. So that statement correctly identifies that 3 and 5 are prime numbers, which is true. It then states 3 plus 5 equals to 8, which is also true. However, the argument incorrectly concludes that 8 is also a prime number solely based on the fact that 3 and 5 are prime numbers. Are you getting my point now? I will show another example before ending this session. This one, since x equals to 5 and y, so now you might be thinking this is very simple, 3 plus 5 equals to 8, so what? We know that 8 is not a prime number. But my point is not that. My point is that what is the fallacy that we are trying to identify that? Now, Shashank was telling that what kind of a critical thinking that we need to do in order to, in physics and mathematics, this type of a mathematics. Now, you see, this is also true in physics and mathematics. Because when you're making an assumption of physical theory, physics, gravitation, whatever, you need to be aware about those things. Since x equal to 5 and y equal to 2, x plus y equal to 7. So we conclude that from here that x minus y equals to 3. Now you see what happens is over here. In this example, the fallacy being committed is known as the affirming of the consequent fallacy. Now, what is that? It occurs when someone mistakenly assumes that if a certain condition implies a result, then the presence of that result implies the presence of the condition. Obviously. Now, to identify this fallacy, we need to identify what is the error. Now, the statement says x equal to 5, which is correct, y equals to 2, that is also correct. Then it tells x plus y equal to 7, that is also true. However, the false argument, what is a false argument? That x minus y must be equal to 3 based on the fact that x plus y will be equal to 7. So if x plus y equal to 7, then obviously x minus y will always be equal to 3 because 5 minus 2 is 3. But the fact is not that. Now, if I assume that x assumes another value, say for example, and y assumes another value, then obviously x minus y won't be equal to 3. So the fallacy lies in assuming that if the sum of two numbers, that means x plus y, is a certain value, only if x equal to 5 and only if y equals to 2, then x plus y equal to 7 and then x minus y equals to 3. Then the difference must be a specific value as well. However, this is not necessarily true. In this case, it is possible that the values of x and y could satisfy the condition x plus y equal to 7, while result will be different for different values. That means I have to use a condition that if and only if x equals to 5 and if and only if y equals to 2, then this statement stands true and that statement stands true. But here it is shown that it is since x equal to 5. So that is called the affirming the consequent fallacy. So you need to be very specific in mentioning what is that. We have other things like making generalization, mathematical modeling, etc., which I would like to discuss in the next class. But I hope you are getting this point that critical thinking. Now, this is that kind of a thinking, again, as I told you, that you have to practice. Take up a single statement. If it rains, then it is cloudy. Say, for example, if I take up this kind of a statement and do a start a critical thinking, how I am based, how I am doing this on the basis of that. What is my data? Data is that it is cloudy and hence it is raining. But could there be a possibility that without cloud there is a rain? If that happens, then what would be my statement? What would be my data? What would be my experiment? And what would be my outcome? I will come because this is very closely related to mathematical proof writing. I have already made one video, but I was just going through my laptop. I've got series of good exercises which you can practice and we can talk in order to learn how to write a proper mathematical proof. And once you learn that, I can tell you, this is, for me, it is one of the toughest challenge in mathematics. If you do that, you're good in calculus, in real analysis, in topology, in differential geometry, anything you can do. So we need to practice how to write a proof-based mathematical system. I understand all these are going a little bit haphazard. The math is very important. Yeah, haphazard. So I am making a big plan to make this all in a sequence from January 2024. So this time I'm trying to get to all of you to understand what things are, but in a process, proper way, one by one, each class throughout 7 days. No, I have to get 1 day rest for me also. That needs to be arranged, and I will do that. I will announce it, no problem. But you see now that critical thinking is not listening to physics for students lectures, it is about practice. So I would request you, take a mathematical statement, try to prove it, go through the analysis, etc., which I have given. If you want, I can share those points also, because I don't have a website. Possibly you can connect to my physics for student Facebook, and let us make a group where we can discuss all those things, because that would be important. You can ask me questions over there also. So let us make this group very important, because there only I can upload PDF files, I can discuss, etc. So this is my Facebook ID. You can just like and we will share. So that's all for today. I will be live with a very important person tomorrow at 7 o'clock with Professor Arun Kumar Pati. And I just want to announce you, I got another date on the 30th of December, starting around 8 p.m. Indian Standard Time, with a professor called Professor Lindsay George from IIIT Kottayam, speaking on machine learning, data analysis, and artificial intelligence. I will soon announce the date and time, 30th of December, starting 8 p.m. Indian Standard Time, right on this channel with Dr. Lindsay George. She is an assistant professor on machine learning, data analysis, and artificial intelligence at Kottayam IIIT. Thank you very much. I hope you like this. We will continue. I understand it is very counterintuitive. Please do practice. Please do practice. Yeah, I am trying to find out somebody who is a mathematician. Karan, you have told me the right thing. I am trying to find out, I'm trying to connect somebody with pure mathematics, because that is also, thank you, Mr. Shounak. Thank you. Thank you very much. So the thing is that I am trying to get him, because I also wish to, take up a pure mathematician and share some very important things. So whatever I am getting, I'm trying to do that. Thank you very much, and let us practice critical thinking. Otherwise, it won't make any sense. Again, a request: please put up a kind of a comment after we end this session, because I would like to read these comments, which becomes very important. Do share, subscribe to my channel, Physics for Students. A lot of new updates, a lot of new things, and a lot of good shorts are coming up by 2024. It will be a complete overall change in this channel. A lot of many things, live classes, complex analysis, real analysis. So I'm trying to make a complete changeover from 2024. So it would be the same channel, same videos, but it would be a complete change. I think you have seen one video, one shots on Mariam Mirza Khani, another on Dr. Abdul Salam. So I'm trying to improve those shots quality, not only just by speaking myself, but making better shots, better videos, and better live classes. And we will maintain a routine, one day on complex analysis, reanalysis, general theory of relativity, and everything. So I will try to make 6 days a week, and we will follow a routine. Otherwise, things are all going. You remember when we did tensor analysis? Anybody remembers? It was almost around 20-25 days back. After that, we have never revisited tensor analysis. We are learning so good. Why? Because we don't have a routine. So we need to have a routine. Otherwise, things are going in a problem. And I'm also so busy that, yeah. So anyway, thank you very much. Be there tomorrow at 7 o'clock. I think we will have a nice session. Goodbye. Goodbye, everybody from India and abroad.